Sorry about that being cut off in the last video. I was having some technical difficulties, but now that we're back up, we can actually finish with problem number 9. So basically, we are given. Let me pull back up our document. Let's see if I have it still up. Let's see which problem is this. Yeah, here we go. Here's our question. Problem number 9: a 66-kilogram astronaut is stranded at a distance of 12 meters from a spaceship in free space. In order to get back to the ship, he throws a 50-kilogram piece of equipment with a speed of 4 meters per second directly away from the spaceship. How long it will take the astronaut to reach the ship? So I've basically drawn out a quick diagram. Always draw out a quick sketch. There's my spaceship. My distance from the spaceship is 12 meters, and my astronaut is 66 kilograms. So he looks just like a pole. Then what he's doing is he's throwing a little object, a 0.5 kilogram object, away from himself at a velocity or a speed of 4 meters per second. And what we need to do is we need to find, actually let me pull that back up, what we need to find is how long it will take the astronaut to reach the ship. Okay? So, to find out how long it will take the astronaut to reach the ship, we're first actually going to look at our distances. It's good to actually be able to know where we're going with this. So, first of all, we know that this 4 meters per second we can use. We know that the distance from here to where the object is will actually be 4 meters, this being the start point, and 4 meters being the end point. So we're going to use that in our equation. We need to know that we need to know our formulas, one for average velocity and one for power. And actually, let me see, I'll put my power formula, here's my power formula. This is your power formula, force multiplied by average velocity, okay? So our average velocity, since we calculated multiply distance divided by time, we do not know our time. This is actually what we're looking for. We're looking for our time. So to look for our time, we're actually going to divide our distance that we're given, and this is going to be our 4 meters that we have from here, divided by your time, which is unknown, and we're just going to plug that in where our average velocity would have been. So you can see that I have, I'll move this out of the way, 4 divided by t, and our force is just going to be 4.905. And to actually figure out your force, this is kind of funny because this problem is supposed to be taking place in free space, but the only way to calculate this force is multiplying the 0.5 kilogram object multiplied by 9.8, which is the gravitational force due to acceleration. This only happens on Earth, so it's interesting that this is required in the problem, especially when it's in free space. But it doesn't matter. This is going to be important. We can take this, we can plug it in, and we'll get this as our result. That'll be our force, okay? So actually, I'll take these boxes off, but that's basically going to be your force. Okay? So, once we have that plugged in, we need to set it equal to something so as to solve it. So we also need to account for what's happening on this side. Okay? We have our 12 meters between our spaceship and our astronaut, and we know that our astronaut is 66 kilograms. So we're going to use this right here to solve for that. We have a 66 kilogram astronaut. Again, since even though this is free space, you have to use that same gravitational force, 66 multiplied by 9.8, which is the gravitational force due to acceleration, again, and we have to multiply this by 12. And this is basically your force times your distance. So we're using a force times distance on this side, and we're using our power formula on this side. This is, I'm finding, is the easiest way to set this up. So if you'd like to, you can actually, when you encounter a problem where you're throwing an object or some sort of material in this direction, and you're trying to find out the time it takes for him to move in the other direction, you can use this formula. So it's kind of interesting how this works. Yeah, I'd like to also point out just a quick interesting thing, is that I tried using a momentum equation to solve for this, and you do not want to use this equation. Personally, it'll take too much time, and you probably won't come out with the correct answer, so it's just a complete waste of time. So we'll forget about that, and this equation, this problem here, is what we're going to use. So you're going to come up with a final answer of like 769.3 or 5, and you're just going to round up. Sorry about that. I don't know what happened. I think a mark came in on our scan, but this is actually 777. And we're going to set that equal to our power formula, which we found here, right? So once we set it equal to each other, we're going to solve, divide by 4.905 on both sides, and then you're going to divide by 4, and your final answer is going to be 396 seconds. And remember the units, because you're solving for time, so you're going to have to remember your units, and there's your seconds. So this is your final answer, and that's problem number 9. Okay, let's see if we can squeeze in problem number 10. It looks like we have enough time. Let me see if I can pull up number 10 here. Okay, so number 10 is a 51 kilogram woman runs up a flight of stairs in 5 seconds. Her net upward displacement is 5 meters. What is the average power generated by the woman while she is running? Here again, you need to know your formulas, your power formulas. So thank goodness we can use our formula sheet or formula page. It makes it a whole lot easier, not as much work. Actually, what I'm going to do is I'm going to pause this just real quick. I'm not sure if you guys will be affected by it. But I'm going to move the screen down because actually, no, everything fits in here. Don't worry about it. Okay, so we'll write out our information. We have a 51 kilogram, let me pull up our info again. There we go. Let's go back down. Get 10. Okay, we have a 50, nope, wrong one. Don't worry about it. 51 kilogram object. A 51 kilogram woman running up a flight of stairs in 5 seconds. Net upward displacement is 5 meters, so I've drawn our steps. You know, it's 5 seconds, 51 kilograms. And we're looking for the average power generated by the woman while she was running. Okay, so I'll close that down again. So we know that power is equal to force times average velocity. We know that average velocity is displacement divided by time. Our displacement is 5 meters. Divided by our time is 5 seconds. That is equal to 1. We can plug that in here for average velocity, so I'll write that out. Make it a little easier. So what we'll do is I'll actually write out our final, and we know that our force is always the 51 kilograms as is here, multiplied by 9.8, which is the force due to acceleration. Again, this is the mass versus force. We have our mass. We're trying to convert to force. So here we'll actually be multiplying by 9.8 to get our final force. Okay, and that's going to give us our excuse me. So 51 times 9.8 is basically going to give us, let me pull that up there, it's going to be 51 times 9.8. That's going to give us approximately 500, right? So we're going to use that 500, and we're going to divide by 1, or we're going to multiply by 1, and we're going to get 500 again. So I'll show you where I am at the moment. I'll use the text box. Let's see if my text box is working. Yeah, here we go. So our power is equal to our force, which is 500. Remember, it's in newtons, multiplied by 1, your average velocity. You can put that in meters per second if you like to. So your 500 newtons multiplied by 1 is equal to 500, but you can leave that as 500. And remember, it's going to be 500 watts because power is measured in watts. Let's see if I can, yeah, here we go. So this can equal 500 watts. And if they wanted it to be kept in watts, you can leave it like that. That'll still be correct. The answer actually asks it for in kilowatts. Well, not specifically, but they put in kilowatts. And if you would like to, then you know that kilo is 1,000. So I'll put that in here. Kilo is equal to 1,000. And all you're going to do is you're going to take that 500 watts and you're going to divide it by 1,000. And that's going to give you 0.5 kilowatts. So I hope that helped you with your final problem, your sample final problems for your final exam. Happy studying. Bye.